Assalamu alaikum wa rahmatullah and good afternoon to all of our beloved viewers to the Voice of the Cape's YouTube page and the VOC's Facebook page. My name is Abir Adams and it gives me great honor and privilege to introduce our esteemed facilitator for today's Matric revision session. And this is the Voice of the Cape's online Matric revision program for 2024 and is proudly being sponsored by the Two Oceans Graduate Institute, which is an accredited online platform where you can become a primary school teacher or a high school teacher by studying in the privacy of your own home. If you'd like to find out more information, you may visit their website www.togi.ac.za or you may contact them on the number 021 829 7015. Without further ado, as we now continue with our matric revision series and one of the last sessions, particularly for EGD, we are joined by none other than our esteemed facilitator, Mr. Riedwaan Bassier. We'll be going through content and we'll be concluding content on engineering, graphics, and design in today's session, inshallah. As a reminder, please, all of the matriculants out there who are embarking upon your NAC examinations, we wish you everything on the very best. And please forward and share this link with all of the matriculants out there who are preparing for the examinations, particularly all the EGD students, inshallah. Without further ado, we immediately hand over to Mr. Bassier to facilitate the last session, inshallah, for engineering, graphics, and design. All yours, sir.
Shukran Amir, shukran so much. As you've mentioned, it is in fact the last session that we're going to have, and we are going to cover two questions this afternoon and making sure that you are ready for next week, Wednesday at 2 o'clock when you are going to be doing your paper 2 EGD exam. So without any further wait, we will continue with our session, and I'm sharing my screen just to show you exactly where we started and where we ended off. So we are currently busy with paper 2, which is your mechanical drawing paper, and we've done all of these already, question 1 and question 2. And today we are going to conclude with question number 3, which is isometric drawings, which is a big part of EGD. And then we are going to move to question number 4, which is one of the bigger drawings that you will have in your paper, also ranging between 90 and 95 marks, which is also just short of 45% of the paper. So it's very important that grade 12s must engage with this particular question and spend at least an hour and a half on this question because of the magnitude of the mark that we have in this particular paper for this particular question. And you will see you can either get a front view, which is going to be section, and then there will be either a top view, or it can be a front view with a left view, a front view with a right view. So they mostly, if you look at papers, there will be two views asked, either a front or a top, or front or left, or front or right. Very seldomly will they ask three views because it takes up quite a bit of time for you to be able to do three views. And if they do ask three views, then of course the drawing will be much simpler and you will only have one cut section. So today we will sample one of the drawings. So I'm going to just go and touch on isometric drawings first. So I've taken this particular isometric drawing, which is from the 2023, which is last year's paper. Now, if you look at the drawing that was asked last year, and I want to read the information to you so that you can merely skim read tomorrow, because the information in the instruction is pretty much the same. So you don't need to do hard analysis once you have done maybe one or two of these in the past, or do it as a revision. So what is given to you, and you please analyze that there's a front view, and you need to know where the front view is. This year, learners, is the front view, and I actually want to sort of label it there that is the front view, because this is how you are actually going to ensure that you understand it well. So that is your front view that you will see here. And then, of course, you will have a top view, which is this over here. That's your top view because it is in third orthographic projection and and it means that the top view is actually at the top. Okay, so that's your top view that you will see here. And then it says here there is a right view, which is on the right hand side of your front view. So that here will be your RV, which is your right view. And for you to understand it like this, it gives you some sort of an idea of what you are busy with and how perhaps the different parts are formulated, so that you can unravel it and be able to put it in a drawing. And then it continues where it says here, it is a sliding guide, of course, a casting. And then the position of point P has been given to you. So you're going to find point P right here at the bottom. That's where point P is. And you can see there are starter lines. Now, the wonderful thing about isometric drawings is that the lines can only go to the right in 30 degrees angle, 30 degrees, or to the left, 30 degrees, or straight up. So those are isometric lines, 30 degrees to the left, 30 degrees to the right, or straight. In very similar cases, or not similar cases, very odd cases, you're going to have non-isometric lines where you're going to have slants of something. All right, for example, which I'm drawing right here at the moment. That is just a sample of what. So all these lines are all parallel, either to the 30 degrees that way, 30 degrees this way. And then you will have the non-isometric lines, which you will see here. Okay, so that is basic information that you need to know. Now, if you look at this particular drawing here, don't just start. Please look at it, analyze it, make sure you understand it really well before you actually start drawing. It is important for you to plan at least 5 to 7 minutes this drawing, and don't rush it. And when you do the planning of maybe between 5 and 7 minutes, even up to 10 minutes, and you understand what needs to happen, then you will make up that time drawing it, because you know exactly what to do. You can, and your planning can even be sketching. Make a little sketch here, and you don't even need to erase it. You can just leave it there, because we understand as markers that learners do planning on their page and they can't take extra pages into the exam. So if they do a bit of rough sketching, maybe here on the side, we understand that. We're not going to mark you down for that. What is very important is to look at the different dimensions, as you can see here, and analyze the different dimensions. Sometimes you will need to look at this dimension over here from here to there, but you won't find it here, but you need to scroll up and you need to make sense of the dimensions that links up with that specific part. So it's all about coordination. Anything that you can't find here must be transferred to this maybe view, where you will see that that part there is in fact 12. And the arrows will indicate exactly where it starts and where it finishes. Okay, so that's important. And you got to make the correlation between, there is an upright part here, which is that part there. You can obviously just sort of break it down as a base there. There's a base, which is this base that you are going to see here, right? And I'm not even doing the insert parts. And then there's an upright part that you are going to see here, right? But if you view it from this side here, that upright part actually takes the format of a hexagon. And there it says top half of a hexagon. Then this part here, as you can see, will be a circle. It's a cylindrical shape here, a cylinder. And it has these attachments on the side and the front here, which makes those things the support structures, which is ultimately called a web or a rib, because it serves as a support structure. You will see a dash line here, and then you will of course see that there's a little slanted inside part here that you will see as well. Then you see a whole lot of dash lines here. What are those dash lines? If you look at these slanted sections here, those are the slanted sections that you will see here that will serve as those dash lines in your top view. So you got to make sense of that. And then there's a bar at the bottom which is attached to this component here, which basically means that this bar is 24 in width and it has a height of 16, and it runs underneath, and it sort of, as you can see here, goes past the actual base and comes out the back quite a lengthy distance of 55. So you got to make sure you understand the actual item that you need to draw, and maybe make a little rough sketch of it. Even if you can't draw it properly, a rough sketch allows you to actually just get a bit of a kickstart so that you have an idea of what to do to draw the base. And then once that drawing is in motion, momentum will then kick in. And that momentum would be that the lines will actually guide you, and eventually you will have a completed product. Okay, so just to show you how this is put together, very importantly, there are about 3 things in here that are higher order. As a grade 12 learner, you need to know how to draw the circle, right? In isometric view, you need to know how to draw that circle and do the certain quads construction that you will have here. You need to know that. That's a higher order. You also need to know how to draw an auxiliary view of the hexagon, so that you can import it, because they don't actually give you these distances over here. So you need, or you are forced to do an auxiliary view. And for the auxiliary view, you actually get a marks as well. So that is important. And then lastly, the third item would be these slants that actually have degrees to it. So they don't tell you how much in it goes. You're not going to see, they don't tell you how much that distance is, but you've got to work it out graphically. So you've got to draw that part as part of your auxiliary view, which you're also going to get marks for. So remember, the circle, the hexagon, and an angle. Those are 3 important things that I advise you to please go through and find it in a drawing, because those will be evident in your exam coming on Wednesday. Let's take a look. I'm going to stop my screen and I'm going to share the way the drawing is done. And then, of course, we can basically see the construction of the isometric drawing. So I'm just loading it at the moment. It's loading at the moment. So right. So if you just give me a few, there we go. It loads perfectly. It just takes a little bit of time to load. And now we have it. Let me just enlarge it for myself so that we can see what we're actually doing here. So if you look at the drawing, what I do when I start, and this is the planning I'm talking about, where you actually just ensure that you understand what the different parts are and how they correlate with one another. So I have a tendency to do this planning before the exam, before the actual testing of this particular drawing, where I just draw certain parts up and make sure that they link with one another for me to be able to get all the dimensions. So you will see here, I draw all my lines up onto my 45-degree line, and it started with the most outside point, just for me to see when I am going to draw it, an easy way of understanding it, and an easy way to make sure that I have my measurements right where I need to have it and what it is, of course. So that's the first part. And then what I am going to do next is that I'm actually going to start my drawing, right? So I would advise you to do that as well. So I'm going to now start my drawing. After that, I'm drawing my 3 lines, and there you will see that I'm actually doing my dimensions for my base. And here you will see that I easily construct my base. There we have it. So can you see my height now has been determined from my base? There's my width, and that's my length. Now, as you can see, very importantly, the orientation of the drawing is very important, because it counts for 2 marks. If you orientate it incorrectly, then obviously you're going to lose 2 marks, or you will not be allocated 2 marks. So in this particular activity, where my cursor is now, that is point P. So you're going to make sure whatever's on the right of point P is going to be on the right here. Whatever is on the measurement on my left of point P will be on this slanted 30-degree section here. Okay, so that's very important. And there I've drawn my base. And now, I manipulate it. Now I'm going to draw the wall at the back here. And I'm not going to draw it immediately as a hexagon. I'm going to get my thickness. And there I draw my lines up like that. But before I actually can conclude the top, because I don't know what the height is. I really don't know what the height is. And that is why the examiners force you to actually draw the hexagon. So now what I'm going to do is I'm going to find a blank space over here, right here, or anywhere on the page where I can actually draw the half hexagon, right? And they give me one side. So I'm going to do that. There I do the one side, and then I can easily check my angles. Look how I check my angles, right? My angles have been checked, and there I am drawing my half a hexagon. I take the same side which has been offered in dimensions, and I just mark those two sides, and there I have my half a hexagon, right? And then I'm going to box it. As you can see, I'm boxing it. Why? Because I need these omitted sides here. So that is 48. If I'm not mistaken, that means the two sides here will be 24 and 24. As I measure, then obviously 96 my whole length. And then from there to there, it is going to be 41 from here to here and 96 over there. Now I have all my measurements. Now I'm going to import it. And you can see here, it has a height here, which I'm going to import it on, and I create my height, which is 10 millimeters. And then on top of that, which I'm drawing now, I'm going to add my box first. So I'm going to draw my 41 millimeters up and draw it as a box first. Right? Here you can see, there's my box format. Let's first stop at the box. Okay, there's my box. And now I'm going to take my 24 from the sides and then just slant it down as I have it there. Okay, great stuff. Look at that. Import it onto that space over there. You will see it all comes from my instructions and my drawings. So that's the 24 that we have here. That's the 24 that we have there. This is the 41 that you will have from here up till there. So that has been imported. Now you can see how I import the hexagon, right? That's the first higher order part which you have completed, right? The rest of it is just standard things that we have to do. We're going to continue, right? And what we need to do is that there is, however, an insert, and that's going to be in the middle. And you will see now I've created the distance by getting the half, and both sides of my half, I will have that. Here's my insert part which I've created. And now I know that I can bring my center point down, go to the one side, measure to the one side and measure to the other side, and then simply just drawing the slanted section in from that particular corner as it is indicated in your top and your front view. And there we have it. Easy as that. Look at that. There it slants down. Of course, that part will not be seen because it will be covered by that corner over there, but that will be seen. There's my insert part. My hexagon part is finished. Let's move along. And now I'm going to go and I'm going to work on my bottom section here, which has the two slanted sections. And here you will see I find myself a blank spot and I draw that auxiliary part there. And that auxiliary part will tell me it is a particular distance in height, and it will have a slanted section of 60. And once I do that, I will easily now be able to determine what the distance is between that point and the slanted section. You can see in the video how I do that. It's measured, and there I write the distance down which now can be imported again onto your actual drawing. And that's a very important part of your isometric drawing, to be able to do that. But let me say, hypothetically, should you be not able to do that, you of course can play the guessing game, right, by just doing a slant. We're only going to penalize you on the one side because you have incorrectly sort of drawn the line to the wrong point and the angle is wrong, because you haven't sort of established what the angle is, and that would be the reason for us not allocating the auxiliary mark and the wrong mark on the drawing. But because you repeated that on the other side, we cannot penalize you twice, and we will reward you with the incorrect one on the other side. Just keep that in mind, because all of this would be positive marking, and it's based on that analogy that I just indicated to you. So now I'm going to box that, and then I'm going to apply by importing this into this space over here. And now you will see there's my measurements on both sides, and I'm simply going to slant that like that. And I'm keeping my drawing faint. I'm not drawing anything dark because I need to also look at my cutting line a little bit later on. Then, learners, my main focus now is going to be on the base part, that rod, or not rod, but the solid piece of square rod, I can say, is that runs at the bottom. So I created my center point, and it's 24, so I go 12 and 12 on the side. I extend those lines further, as you can see, and that length there is also 16. Measure my 16 in front, and then just block it the way it is, down, 16 down, and for you to be able to get that little part that comes out in front, as you can see in my drawing. Nice and easy. So there we have that front part, right? 24 out, 16 drop, and it disappears underneath this base part. But of course, it comes out on the other side. So you got to make sure that, you know, at the later stage, you will have this lengthy part coming out on the other side by adding all of that, which is going to be 176. If you add up the distances at the top here, and you will eventually see that it comes out at the back. And there, I'm just drawing that line there just to indicate where it comes out at the back. Okay, so that's important for you also to note. Don't forget that part, that it actually comes out, and the 176 will be indicated here at the back. And you can see there I've indicated that the back part coming out, which is only a part of the entire length. Okay, once I have that, I now am going to focus on my circle. And for me to be able to draw the circle, another higher order, I'm going to create my center, as you can see there. There's my center. My circle has a particular dimension in terms of the diameter. What I do is, as you can see here, I create my radius, which is from the center that way, and I take my compass to create a perfect square. So that is all the four sides, or the quads, to be created now from that dimension of my circle, the diameter, which is now my radius, to create the four quads. And I box it like that. It's obviously going to be a squashed square, which is a rhombus, basically, you know, because that side is exactly the same as that side. So mathematically, it's a rhombus. But you will find significantly that there are two obtuse angles, right? Obtuse angles means they are bigger than 90, and two acute angles. And then you will have those projected up, which is the box, so that you can do that same construction at the top. So you're going to have that construction at the top there. There it is. And then, of course, you're going to do the construction by connecting the two acute angles and opening up a V-frame from one of the obtuse ones, like I'm doing in the drawing now. And this is the construction that you've done since grade 10, which you need to know. I'm going to open it up like that, and I'm going to draw my one side of my circle, which is my isometric circle. So I'm going to draw that side faintly and go to the opposite side. And I'm going to do that as well. And then my shorter sides of my circle, because you must draw an isometric circle in 4 parts, as you've done before. There it is. And then, of course, the other side you're going to do. And there you have a full circle. Now you must just project those things down. Right? You're going to project that down so that you will have the bottom section as well. Then, of course, the support structures must now come in here. Right? After that, you'll see that I'm doing the very same thing at the bottom. Right? By drawing a double circle like that. There we have it. And then I will connect the sides, as you can see, which I've done. Now, certain parts will appear as dark lines and others will not appear, but you have the construction there as well. Now I'm going to fit in my 3 ribs, my support parts, which are my ribs or my webs, as the mechanical term analyzes that to be. And it slants from the center of that circle, which means that it's 8 millimeters, and you go 4 and 4, whatever the measurement is, you go half and half. And you go down and it formulates that sort of triangular shape there. And then you do the exact same thing on the other side, creating the centers first, and then the half on both sides of my centers, allowing me to formulate the rib there. Right? And then I'm going to do it in front. Now, of course, when you do that triangular shape there, then there are corners that formulate right here on the side and at the bottom. And here I'm doing the front one. Both dimensions are given, and then I do it on the left and the right of my center. My corner formulates here, and there's a corner formulating at the bottom as well. And now, guys, there I have my entire faint drawing. Now, before I can darken it, I have to take into consideration that in this particular instance, there's a cutting line. If this was a drawing without a cutting line, and I'm hoping the exam is not going to ask for a cutting line, because a cutting line sort of intensifies the drawing. It makes it more exciting, but it also makes it more difficult, and more analytical knowledge then needs to come in for you to be able to do the cut. So I'm hoping that you're going to have one without a cut, but in this case, let's prepare for the worst. There is a cut, a quarter part of that circle will be cut out, which you can see it's indicated in my instruction. And now I'm simply going to draw in my cut section. Right? I'm going to draw in my cut section. You will see I'm darkening everywhere I'm going to cut right through. And I just going to stop it in a moment just to show you how I do, just before I do the hatching. Right. You will see here that the cut is being done and it's perfectly in the middle. And I'm creating now my lines for my web. And I will explain that after I've completed that line. Now, you will see here, learners, the cut is perfectly in the middle of my web. And a quarter of the circle perfectly in the middle of my web, and wherever there are corners, it goes down right underneath. So that's the part that's been cut and taken out. So you need to show that, and by showing that, you also need to hatch it. So what we're going to do, we're going to have a hatching that goes to the one side and a hatching that goes to the other side. All right, here we have it. And then the remainder of that circle will be there, which I'm going to darken, which I have darkened. And then I'm going to just add all the other dark parts of my drawing very quickly. As you can see here, the remainder of that, because the cut section has now been completed. And I simply just add my dark sections like that there. Okay, just to stop it there and show you what it looks like right at the end. Just to complete little bits and bits of touches on this drawing to make it nice and perfect. And there you have your drawing. Now you can see the part has been cut out. That's the remainder of it. right in the center there, you will have how it goes at a 90-degree angle. The hatching goes this side and the hatching falls that side. It cannot be the same because you will be penalized if you keep the hatching the same because it's two different surfaces. Half of my my web remains both here and in front. That is untouched. Everything else is untouched here. It's only this part where the cut section has been implemented and where the cut section has been removed. And that is the detail of that cut section. And that concludes this particular drawing before I go on to the last one. But keep in mind, grade 12s, that it takes a bit of more thinking and planning when you are going to execute the cut section. So you have to draw everything so that you see the whole thing first, and then you apply the cut section. And in this case, you can see how I applied. I took my lines onto the specific sections that will be cut in the middle, right down as the surfaces are sort of panning out, you know, whether it's vertical or horizontal. You take it down and you sort of draw that dark first, and you ensure that you add the cutting line to show clearly the cut section. And guys, experiment with it and see what you can come up with, even if you maybe get some of the parts incorrect. Just so long if you attempt it, there will be some marks that will be embedded in the drawing that we will be able to allocate to you. All right, so that concludes this question number 3. I want to touch on question number 4, which is the assembly drawing. So I'm just going to stop my screening right here for this one. I'm just going to remove that quickly, and I just want to present you which assembly drawing I'm going to be looking at. So I've taken this particular assembly drawing. This is question number 4. You can look at the mark magnitude. It's quite a big chunk, 93 marks, and this was the paper of 2022, 2 years ago. This was the Matric paper that they wrote in November. It's quite a lot of information that goes on here, but I want to show you technique, right? You must be able to execute the drawing because all the dimensions are here. But if you look at this page, it can become very despondent. Why? Because there's a whole lot of things happening here, and the brain is of such an organ that as soon as there are too many things on a page, it shuts down. It just doesn't want to continue, and that's the time when you say, no, I'm giving up, I can't do it. But you got to stay in the fight. And when I say stay in the fight, I mean that you need to analyze and read. And let me read this to you. This is what you're going to do in your exam, because this is all about technique. You read here and you mark, and I'm going to show you exactly what you need to do. So you're going to read here what is given to you, the exploded isometric drawing. So you underlined it. And part of a wobble engine assembly showing the positions of each part relative to all the other parts. The exploded view. What is the exploded view? You take your pencil and you put the exploded view, which is this here, the 3D exploded view. Hold on. You just go take all of this. You take that entire exploded view, right? And you go up here, and let me just make that a little bit smaller so that you can see what I'm doing. And you put all of that sort of in a box like that there. That's your exploded view, and it will stay here. Please take note of this, which is your left view there. That's your left view. Okay, there it is. Take note all the parts that face the left view. So if that's your left view, then that there is going to be your front view, because this is on my left hand side and that's my front view over here. That's how you need to know. And all the surfaces that face your front view. That's what you need to do. Understand from this exploded view. Then further it says here that orthographic views of each part of the wobble assembly. So all the parts are here, and you will see here, there's the part, and you can do a part check. Now, when you do a part check, you're going to say the following. Let me make this smaller quickly. There is a base, right? And what you must do is take your pencil and you put the entire base in one cubicle like that, right? There. Now you know this is the front of my base. That's my front view of my base, right? This is my left view of my base, and this is my top view. But I'm not going to draw a top view. They just giving it for the dimensions because they don't tell you what it is here. You are only going to draw according to your instructions. Piston also in a cubicle. These are not two different drawings, it's two different views. Then you are going to have a cylinder, right? And there's a detail of a particular part of the cylinder. You're going to put all of that in one box. That is the cylinder, it's one component. Then you're going to have here a tension screw. So you're going to put the tension screw, both views of that in a box. Then you're going to have your compression spring in a box. Then you're going to have your flywheel in a box as well, right? All separate components, put and separating them. Then there's a key. There are two views of the key. This is the one view, that's the other view. And then you're going to have your shaft. There's your shaft in a box. You're going to have your washer, which is an easy component, and you have your nut there. And then lastly, there's a crank that you will see here, also put in a box. Now, if you do it like that, now things are becoming more clear, and there is a certain order that you are working with. You know that every time you're going to draw something, you're going to tick off this box here, or you're going to tick off there. I've drawn the base, I've drawn the piston, I've drawn the cylinder, I've inserted the tension screw, I've put in the compression spring. You gotta make sure that you know that. Okay? And this is also part of the planning. And then what you do is, when you are looking at the instruction, because they say here you must draw to scale 1:1 on page 6 here, which is your blank page, right? You must draw only the left half of the front view. So if this is your front view, you're only going to draw the left half. That's the left half. This is the right half. So you're only going to draw the left half of your front view. No, the front view is here. Sorry. This is the front view. It's symmetrical. This is the left, and that is the right of your. So you're going to draw the left side, which is everything in the middle, cut down here. But this side you're going to draw. And then you're going to draw a sectional left view, right? A sectional left view, which is this view over here, where you have a cutting line through everything to show how the components fit together. And that takes a special type of skill, right? So it's all loose components which you're going to put together, but you're going to put it together part by part. And that's why you need an hour and a half for this. And then it says clearly here that you need to do planning, which is essential. You need to draw and comply with the SANS 10111 guidelines. They say that the piston part 7 must be drawn in the highest position. So that's very important, in the highest position. And then you need to show 3 faces of your M16 nut, which is part 5. The compression spring part 9 must be drawn as a convention. Now, you know the convention means that they show you how that is there as a picture, but the convention means, and I want to draw it here, a straight line there, a straight line here, and then, of course, the lines, slanted lines in between, and then a center line in between. That is what they talk about convention. Okay, that's how it must be drawn within that space of 20. So the space from here to there is going to be 20. And then lastly, they say that no hidden detail is required. So you don't need to worry about your hidden detail. Now, when you draw a front view in this case, and it's only going to be half of the front view, You only draw the things you can see from the side, right? Not from the side, from the front, which is only the half part of it. And I'm going to show you now what happens. And then once you draw that first, put everything together, even the nut, and the nut is an important construction which you need to know. And then you're going to draw the left view, and you're going to cut it, and you're going to section it. So that's basically what's going to happen. Let me show you how this drawing unfolds. All right, I'm going to stop. Just bear with me very quickly as I load my video. I'm going to load my video file now of an assembly drawing. A couple of minutes to load. It will appear onto your screen in a few seconds. Because it's a big video, it takes a bit of time for it to load onto your screen. Probably in the next couple of seconds. 5, 4, 3, 2, 1. I'll be with you now. Just allow it to be loaded. Yeah, it takes a bit of time, but I want to show you how this drawing is going to be put together. It's quite a large video file, so it takes a bit of time to load onto the system. Okay, I'm just trying to fast track the process. Give it a few more seconds, learners. Yeah, just having a bit of trouble loading it. Okay, let's try again. Just see if I can load it again for you. Present video file. It's going to be the assembly revision. Okay, there we go. There we go. Thank you for your patience. This is what happens if you have a big file. So now I have, and you can see here, learners, what did I do? Right? You can see how I actually have this all in green. Right? I have it all in green. Just stop it there. My front view, there, it's all in green. I've marked it. Now I'm going to analyze. And you will see that I start with a line at the bottom, and I'm going to draw a line halfway. And everything on my left of that line will be drawn. I measure it out, and then I'm going to do all the construction of my base plate, as you can see. And I put in all my different components, which is my nut and my washer, and my wheel I'm going to put in, which is going to be there. Right. So just to show you here what happens. Yeah. Just to show you what happens. So here you will see, learners, that I've put in all my components that will compile my front view, which is only the half. So I draw a center line in the middle there, and everything that's in half. I've done quite a bit of space planning, allowing me to just draw this part close to my rubric over here, and then I only draw my half. Now, if you draw the full thing, if you draw the full section, and you go over this part over here, the writing part and the marking section, we don't have a problem with that. We're not going to mark you down. If you can't draw it like half of it and you're only used to drawing it in full, that is perfectly fine. We're just not going to take the part that the part that's not supposed to be there. We're not going to take that into consideration when it comes to marks. We're only going to mark the half that's according to the instruction, right, which you have here. So it's simple for you to be able to use the dimensions and to draw it over like this. And you can see I work with center lines. Everything revolves around the center line. It's halfway this way and halfway that side. And everything is according to a cross where there are center lines, and everything happens around a center line, which makes it very easy for you to draw. And once I have that front view, now I'm going to proceed to my left view, and I'm going to simply just start with my base. And just to show you, there I have my base part. First part is done. Right? Here's my base. Just to show you what the base looks like. There's my base part. Right? That's my base. You can see I leave a gap open there because once you have drawn your base, that's the part that you start with, which takes a lot of time. The rest of it just slots in. So you're just going to slot in the other components inside the base. So you will have, for example, the shaft that goes in there. Right? There's the shaft. And then you will also have sort of the pulley part or the pulley or the wheel that will go on there. And inside the pulley and the wheel, there will be a key that will be shown to allow momentum from the shaft onto the pulley. And then I will have my washer and the construction of my nut. And you can see how the construction of my nut would be from my front view, and using my circle template for the little corners of and the arcs of my nut. And please, people, this is a very delicate construction. You need to ensure that you know how to draw a nut, okay, or a bolt. It's very important. You need to know how to draw a nut and a bolt. And if you don't know, I would advise you to go practice, because there's definitely going to come in the exam a nut and a bolt, or a bolt. And the construction of both would be the same, okay? And then, of course, once that is done and the shaft is there, then we are going to add the other components, which is that part that you will see there with the spring, of course, which you're going to put in there in convention format. There it is, right? And that, of course, there, the crossover is the flat, your cross flat that we have on a bolt. And then, of course, we continue by adding the part at the back there, which is my piston. See there, I constantly refer to my instruction page for the dimensions. And then I add my piston, and my piston, of course, is highest position. It is in its highest position. You will see there. And then the part that comes over the piston will just be added, making it very easy to slot in here and covering the piston and the inside. Nice and strategic planning allows you to actually fit in all the components as it is on my drawing. And then once I have all my components, you can see there, nicely fitted in into each other perfectly, I'm going to start with my hatching. And the only things that will take hatching would be my main component, as I have there. And then you will also have your pulley or your wheel in a different angle, right? In a different angle. And then you are going to have your that component which you see here, which is your added to your piston. That will be in a different format of hatching. There you will see it is. And then the different components will of course take different hatching. Now I just want to pause on the hatching part here and just explain a few things before we exit this drawing. Now, very importantly, learners, with the hatching, you will find that you must do your hatching of different components in different directions. So there's 45, there's 60, there's 30. You can use all of those. You can cram the lines closer together, or you can spread it apart. The bigger the component, the more you can spread the lines. The smaller the components, the more narrower the lines are packed together. And you can have different angles of the line to make it clear that you are cutting through different components. And that's very important. And then, of course, people, center lines. Wherever there are center lines, you must please put them in. Wherever there's a center line on a component, you have to put it. There's almost 7 to 10 marks allocated for center lines only. And you know that we work in half marks, so that means that if you have 7 marks for center lines, there will be literally 14 different center lines on the drawing. And you need to find them and put them in, even if you play the guessing game, because the center lines count quite a big chunk of the mark, which is almost up to 10 marks. And if you leave it out, you are actually missing out on 10 marks. So do not forget to add center lines. And if there is a requirement for a cutting line, please make sure that you add a cutting line as well. And the cutting line arrow will be on the side that has the actual section. It won't be facing the section on that side. It will be on the side here that will be facing, that will have the cut section facing away from the cut section. So that is where you put in your cutting line. And make sure that you label it AA, BB, or CC, whatever it is. And the outline, both the outlines, the 2 lines where it starts and finishes, must basically be drawn slightly darker than the rest of the line. So those are all little tips that you need to be able to really get this drawing, a hang over this drawing, and sort of getting the maximum marks out of this particular assembly drawing, because it has a mark magnitude of 90 odd marks, which I said at the beginning, slightly short of 45. And if you can do it really well, you will be close to halfway through your marking of 200. And if you add the analytical, it will definitely push you over 50%. So spend a little time to draw 1 or 2 of these in your days leading up to the exam, and make sure that you understand it well. The concept is very important. They will give you different components, but there will always be a nut, a washer, a bracket, a pulley. Those are common things. Just the shape changes every time, but the concept of you doing it, knowing how to do it, will make it easy for you. And just remember, last thing, if you can't put it together the way it should be, just attempt it in your own way. I promise you, there's marks allocated for putting it together, and maybe penalizing you 1 or 2 marks for not putting it in the proper position as it should, but you will still be rewarded for the components, the lines of the components which we have drawn. Learners, grade 12s, that brings me to the end of our lengthy couple of weeks of revision. I really want to thank you for being part of the session, and I want to thank the radio station, the Voice of the Cape, for allowing me the platform to share some of my knowledge to the grade 12 learners. Both Conita and Amir for just making me part of the team of presenters. I've really enjoyed myself, and I want to take the opportunity of wishing every single grade 12 learner who's doing EGD, and those even who are not doing EGD, well for the rest of the exam, and in particular for those who are writing EGD on Wednesday. All the best, guys. Hope to see a good result at the end. Assalamu alaikum. Greetings to all.
MashaAllah, we say shukran. Jazakallah khair to Mr. Riedwaan Bassier, who so beautifully facilitated today's session. And we apologize for the delay here on our side due to technical glitches, but we hope all of the matriculants are going to be using all of this as a means of preparation for the upcoming examinations. We'd like to once again thank our esteemed facilitator, not only for today's session, but for facilitating all of the sessions dedicated to all of the engineering, graphics, and design students. We hope that you've greatly benefited. And as a reminder, if you'd like to prepare for your last upcoming NSC exam papers, please visit the Voice of the Cape's YouTube page and the VOC's Facebook page, where you'll be able to get content on all of the subjects as you are now coming to the end, or rather as you're concluding the NSC exam period. And this has been the Voice of the Cape's Matric Revision Program for the year 2024. And our proud sponsor is the Two Oceans Graduate Institute, which is an accredited online platform where you can become a primary school or a high school teacher by studying in the privacy of your own home. If you'd like to find out more information, you may visit them on their website, that is www.togi.ac.za, or you may call the number 021 829 7015. Once again, on behalf of ourselves here at the Voice of the Cape, we wish all of you, the matriculants, well as you prepare for your exams. Please forward and share this link to all of the matriculants who are preparing for the exams. We'd like to once again thank our esteemed facilitator, Mr. Riedwaan Bassier, for so beautifully concluding today's session. We wish you everything of the very best, sir, and we wish all of the matriculants all of the very best as you prepare for your upcoming NEC exams. Shukran, Jazakallah khair, wassalamu alaikum wa rahmatullah.